Dum de dum de dum. Welcome back, everybody. In today's video, we're going to be looking at these things called geologic cross-sections, and we're going to learn how to write something called a sequence of events. While you're watching this, I want you to take notes in your Topic 7 note packets, and feel free to pause this at any time you need to. What we're seeing here is a geologic cross-section. It's supposed to be showing you layers of rock inside the Earth. Now, by the end of this video, you should be able to read one of these things like a storybook, but at first glance, they can be pretty confusing. Cross-sections can show us events that happened in Earth's history, things like faulting, unconformities, intrusions, extrusions, tilting, and some other things as well. One problem a lot of people have when they first try to read these cross-sections is trying to visualize what these things are really supposed to be representing. So imagine if you could actually take a slice of the Earth's crust, take it away, and then see what was inside. It might look something like this. As you can see, there's a lot going on under the Earth's surface, and these things are all the result of geologic processes. Now, how did all this stuff form? Well, maybe something like this. So what happened here? In this next section, we'll look at how to decode these things and how to write something called a sequence of events. These geologic cross-sections have recorded events that happened in Earth's history. So when you write out a sequence of events, it's kind of like writing a story of what happened there. In order to do that, we need to identify the events and then list them in the order that they happened. If the events weren't in the right order, then our story wouldn't make any sense. And here's an example. So those were all events of the American Revolution, but those events weren't in the right order. Hopefully you know your history and you noticed that. Here are the same events in order. Much better. We're going to do the same thing with these geologic cross-sections by listing events in the correct order. But in order to do that, there's some rules we have to follow. I'd like you to get out your notes and to copy these down onto page 7 and 8 of your note packets. Rule number 1 is a concept called superpositioning. So think logically. What was here first, the brick wall or the guy sitting on top of the brick wall? Well, obviously the brick wall must have been there first, because if there was no brick wall, the guy would have nothing to sit on. That's all superpositioning really means. Events or objects that are on the bottom of a sequence must have been there first. Things that are higher up in the sequence must have happened afterwards. This helps us to determine the order of events and the age of the rocks in a geologic cross-section. Older rocks are on the bottom and younger rocks are on the top. So write this down in your notes. The law of superpositioning states that the bottom rock layer is the oldest because it was there first. Our next rule has to do with how sedimentary rocks form. As you can see in this picture of the Grand Canyon, we have a lot of sedimentary rock layers, and they're all horizontal and they're all flat. Well, that's how sedimentary rocks form. Write this down in your notes. The law of original horizontality states that sedimentary rocks are horizontal and flat when they form. Quite often we'll see sedimentary rocks that are not horizontal or not flat anymore. And that's telling us something. Something big happened to change them. But whatever changed them happened after those rocks formed. Now we need to remember that when we're writing our sequence of events. Our last rule is uniformitarianism. Say that 3 times fast. Write this in your notes. The law of uniformitarianism states that the forces that affect the Earth today also affected them in the past. For example, we can see erosion happening in streams today, and we can also see the effects of it today. If we see similar effects in another cross-section, we can infer that erosion caused that as well, and the same applies to other processes. So let's talk about what we're actually seeing in this cross-section. All those strange-looking patterns represent geologic processes, like deposition, faulting, folding and uplifting, erosion, subsidence, and more deposition, intrusions, and finally, extrusions. Okay, so we're going to write a sequence of events for this geologic cross-section. I'd like you to copy this down on page 9 of your notes. Now, before any of the things that we see can happen, the rock's got to get there somehow. And the first rock that's got to get there is the one on the bottom. Now, as you can see here, this is sedimentary rock. Our step in producing that sedimentary rock, then, is called deposition. Now remember, when those sedimentary rocks formed, they didn't look like that. They would have been horizontal and flat. But now you can see they are definitely all bent up. This is called folding, and that's our next step. Next, you can see those folded layers have been split apart by 2 things. The first is this fault right here, and that's our next step, faulting. Now cutting across the folded layers and the fault, we see our next step, extrusion. And finally, if you look at the top where it looks like everything has been worn away, that's erosion. And that's our last step. So that's our story. When you come into class next time, we'll discuss in a little more detail on how to identify intrusions and extrusions and some of these other geologic events. But all you're really doing is you're thinking logically about the events that you see and you're putting them into order.